All right. Good. So I want to do a bit of a recap. Let's see. I want to make sure, because I know Tovio asked that I make sure that y'all are feeling comfortable with our list operations, because Tovio will be using a lot of list operations in their material when they teach. So, list operations. This is everything we went over the other day. It's all this stuff, all this good stuff. So I don't want to go over everything necessarily, but let's just pick a top three. Let's say len, len is useful. I mean, they're all useful. Len, count, index. Ooh, and we can't forget enumerate. So len, count, index, and enumerate. So here's what I want to do. I want to do a little poll. We'll do another poll. I'll ask that you don't post anything yet. So we'll do kind of a similar poll to what we did before. Let's see if I can find it and just copy paste it real quick. Right quick. Where is my poll? Okay, this is the class before. Let me find it. Okay. So we'll do an emoji react style here. Oh, if Slack will scroll. So, here's the deal. Len, count, index, and enumerate. So 1 to 3, react with the appropriate emoji here. 1, 2, or 3. How you're feeling about these concepts, about these. If you react with a 1 or, well, yeah, if you react with a 1 or a 2, post in what, which one or all of them that you want to work on, that you need some help with. And I just want to get a sense of where people are at. Okay. It's already a trend. Okay. Dictionaries. We haven't covered dictionaries yet. We are going to get into those. Okay, so I'm getting the sense that for people who want to work on something, want to work on enumerate. I'm not sure everybody weighed in here. I'm only seeing what is this? 13 results. So I know we've got like 23 people at least in class. So go ahead and put in your vote there. Okay. Okay, cool. Yeah, that's actually pretty. We actually have more people for this time than we usually do, which is pretty cool. All right. So let's do a refresher on Enumerate before we continue, because it's a really useful and important one. So let me snag one of my lists here. So let's do something where for I in list, let's say I have a problem where I want to raise each value in list to the power of its index. So how could I do that? And I'm just going to print it out for now. I'll just print out, this is, well, let's call this n, let's call it num. So we're going to print it num to the power of its index. So you might think, okay, well, I guess I could use the index method or something. There's a few ways around this. You might have a few different things you're thinking of, but I want to show you the answer, and it's the answer to any question that follows the form, that follows the pattern of like, you're in a loop, you have access to the elements of a list, and you need access to the indices of that list also. The answer to that question, to the answer to that problem, is to enumerate. So I needed the index, I'll just enumerate, no big deal. IDX, oops, convention. Run it, and we will raise every number in the list to the power of its index. So what enumerate does is it takes in some iterable, in this case just a list, and it lets me, what it does is it gives back a tuple for every element in the list, right? If I iterate directly through the list, I just get each element, right? But enumerate gives me a tuple, which is a data type that we're going to talk more about that's similar to a list. It's similar to a list in that it's just a group of things, right? So it gives me back a pair of elements grouped in a tuple. One is the original element from the list, and the other is the index, actually in reverse order. First is the index, then the element from the list. So I'll show this. Let's just call this group. We won't even think about it as a tuple. So let's just print the group. Or group is a little, I don't know, pair. Pair is better, because that's what it is. It's a pair of things, right? So if I enumerate the list and I do pair, so notice I get these pairs of numbers in these parentheses. Those parentheses actually tell me it's a tuple. If those are square brackets, right, you'd recognize this as a list with two elements, wouldn't you? So this is a data type that's similar to a list, and we can just think about it as a pair, right? So we've got, if you look on the left-hand side, you've got 0, 1, 2, 3, 4, 5, 6. Well, those are the indices from this list, right? If I noted the indices from each element, 0, 1, 2, 3, 4, 5, 6, 5, 6. Okay. So the numbers on the left are the index, and the numbers on the right are the elements from my list. So enumerate gives you pairs of elements with the index followed by the element from the list that you're enumerating. Let's do a quick 1, 2, 3. So where are people at with Enumerate? Is that better? Got a few threes. Threes. Still got a 1, okay. No worries. I do want to get a sense of where people are at. If you're finding this, like, you know, if you're feeling behind, I guess, I'll share a little from my experience. Like when I was first learning to program, I would go to like meetups and stuff, just tech meetups and JavaScript and full stack developer meetups, thinking like, oh, maybe I'll get something out of this, and it would all be over my head. And I'd be like, oh, that was kind of fun, you know, whatever, free pizza, but not really sure what I got out of it. And then like, there were things that people would say, and then years later, it would like click for me. And if I hadn't gone to that meetup, it wouldn't have clicked. It's just, you know, so sometimes there's a delayed response. So just for anybody who's feeling, if you're feeling behind, I mean, I've definitely been there myself, and you can still get a lot out of just keep showing up, keep getting as much exposure to these ideas as you can, and if it doesn't pay off right now, then it'll pay off sooner, or if it doesn't pay off sooner, it'll pay off later. In some cases, way later. So if anybody is feeling left behind, reach out to me. Ask for some mentoring hours, and I will do my best to get you caught up as much as possible. So yeah, cool. I'm sensing that overall it's a general improvement for Enumerate. So in the interest of being able to get through everything today, I think we're going to move on. No worries. Trust me, I was the one for for the longest time. Yeah, it's all good. Okay, so overview. Data types. Abstractions. Control flow. Iteration. We've got your int, float, stir, bool. Bool goes with those. None. We just talked about tuples briefly. Those go here. Tuple. We talked about lists. Abstractions. We've got variables. Functions. Control flow. That's your if, elif, else. I've heard a lot of people don't like to use elifs. They're weird. I don't know how I feel about them. There's other languages that just have if and else, and they kind of chain them together. But Python has elif. But you need it. You do need it. And then iteration, we've got for loops and while loops. So today's topic is while loops. Let's do a bonus thing real quick. So yesterday's bonus thing was importing. Today's bonus thing is workflow. So I bring this up. Some of you who I've met with and worked with may, or if you've seen my study halls, you know how big I am on having good workflow. So this idea of workflow is like, it's not just like, well, do you know syntax? You know, you got to know the syntax of a language to, you know, be able to be conversant in it. It's not just about that, and it's not just about like, well, can you use that syntax, you know, which are just the details of the language? Can you do problem solving? Implement algorithms. Oh my gosh, I can't. I can't. I'm not gonna try to spell that. So problem solving. It's like how you go about implementing everything, right? So workflow is I think about it like it's the, you know, the syntax, which is the actual language, and then you have syntax and semantics, right? The rules of the language, and then you have the problem solving, which is like what you're doing, and then you have workflow, which is how you're doing it as you're doing it. Like what's the process of actually getting this stuff down, you know? So, you know, I'll give you an example of a workflow. So I've got a project, and I could approach this project in several ways. I could say, well, you know, I know what I want this project to do. You know, I know what problem I want it to solve. So let me go about documenting every aspect of this project. You know, I don't want to write any code that I don't have full documentation already written for. And we'll write all this documentation, and then before we get into any code, let's define every possible use case that this code might be implemented in. So let's define and anticipate every possible use case slash scenario. And let's decide what we're going to do, decide how to handle each scenario. So this is a workflow. It's not a good one. It's actually for those of you who know about formal workflow stuff, you might be realizing I'm describing something often called waterfall, which is a metaphor used to describe a top-down sort of linear workflow that goes in one direction. It goes in one direction because, you know, we start by having a fully realized vision of the project before we do anything, and we start the project before we actually start implementing any part of this project. We start documenting every aspect of it, and then after we're done documenting everything, you know, we're going to define and anticipate every possible use case or scenario that this, you know, the thing that we intend to build might find itself in, and then decide how to handle that scenario. And mind you, that this is before we've written any code, and there's probably, you know, another few steps here before we get to like write some code, right? So this is kind of an extreme. There are and this describes like workflow at scale, at the scale of like perhaps a large project or a small project, but a whole project. But you can extrapolate the reasoning here to like writing a single function. And that's kind of more what I'm interested in, is like, how do I, as a programmer, a person writing code every day, how do I use good workflow principles to help me do my job quickly and easily? So, I think a lot of people have this idea, oh, I don't want it to be too easy. And I'll tell you, I do want it to be easy. I absolutely want it to be easy. I'll pull out all the stops to make it as easy as possible, because the easier I can make my life coding, the easier that if I can implement systems that make it easier for me to produce code quickly and with less effort, then I can spend my time thinking about aspects of the problem that are more interesting to me, or um, more important to think about, right? I spend less time like grinding away at an implementation and more time getting more done, right? So, or, you know, taking a longer lunch, or whatever, whatever payoff that's going to give you, right? um, so, so this is kind of a notorious workflow. Like I said, sometimes it's called waterfall. Um, so it's this idea that you have to have a fully realized idea before you start doing anything. And I kind of often um, recommend doing more or less the opposite. Not always. I mean, there's a balance between, you know, thinking enough about the problem before you start, and then having then thought enough to now start solving the problem. So I kind of like will exaggerate this. Sometimes I'll go through code wars on like study halls, or even just the learn problems, and I'll try to kind of exaggerate my process a little bit, um, to show that you can kind of do it in I don't really want to say sloppy. Sloppy makes it sound like kind of unprofessional, but like you can take kind of let's say a really easygoing approach to a lot of problem solving. It can be very casual. So I'll go into solving a new problem, and mostly what I want to know, if I'm writing a new function, we'll just constrain this down to just one function, right? If I'm writing a function, I, I really want to know what the inputs and the outputs of that function are. And if the relationship of the input and the output doesn't tell me what the function does, then I also need to know, well, what does this function do? So I need like a description that's supposed to, you um, return the summation of this list, or um, it's supposed to give me, combinations or factorial, or just to define something that it's supposed to do. So basically, this is back to ion, and this is why I bring it up. When you're starting a new problem, you don't need to have a fully realized, you don't need to have really much of a sense at all of what you're going to do to solve it. You just need to know what the inputs are, what the outputs are, and any notes or description that might seem important to help you understand what you're supposed to do. But the reason I mention this is that I see a lot of people put a lot of time and energy into thinking about how, like, what they're going to do when they start coding. So what I recommend, if you're thinking, oh, then I'll write this line, and then I'll write this line, just stop that and just start writing. that is, when you're starting to think about what lines you're going to write, that means you should have already been writing. You should already be writing code. So I'll show you a good workflow. So let's say I have a factorial function. Factorial. So I know the input is an int. And I know the output, which is the return value, let's just call it a return, is also an int. And then any notes, returns the factorial of the input. Input. Okay, we'll just call the input n. Okay, so it takes in a number, we're going to call it n, it's an integer, and it returns an integer, and the notes are just that let's say computes and returns the factorial of n. So inputs, outputs, notes. So first thing I like to do is call the function. Factorial. So factorial 4, factorial 5. I know factorial 4 is 24, factorial 5 is 25. It's not 25. I don't know what's wrong with me. 120. It's been a long day. Okay. Okay, so the reason I like to do this first, it might seem really weird, like I'm invoking a function I haven't defined yet. Like you might think, oh, you're just gonna give you an error. Yeah, it's gonna give me an error. I mean, that's fine. This is, if I ran this code right now and it didn't give me an error, then I would know there was another problem, right? Like if it gave me a list, I'd be like, oh, well, I have to go fix something evidently because this isn't doing what I want it to do. So now that I know, I'm getting an error. Okay, so we'll write the function head now. So I'll say it takes in n. I'm just going to throw in a pass for now. So the reason to do this is you can do multiple tests if you want, but at least do one. Don't do 0. At least do 1. And the reason to do this is it forces you to write the whole thing with an input, and it reinforces that so that you know what the type of the input is. So when I'm keeping track of inputs and outputs, you'll notice that I'm always mentioning the type. I don't really care what the name is, I want to know the type. Often I don't. Sometimes I need to know other details about it, like, for example, the sum function takes in a list, but it's not just any list. It has to be a list of numbers so that it can sum the numbers, right? If there's strings or some other type in there that can't be added numerically to a number, then sum isn't going to know what to do. It's going to throw an error. So when I'm thinking about inputs or outputs, I usually don't even have that level of detail about the input. I don't even need to track that level, but sometimes you do. So sometimes you need to know a little bit more. Is this a list? Okay, is it a list of integers? Can it be any list? Something like that, right? Like, does this number need to be between a certain boundary? Is that boundary fixed? Like, does it always need to be a number between 0 and 1? Right? Like if a function takes in a float value, will any float do, or perhaps it needs to be a floating point number between 0 and 1, or between 1 and, if it takes in an integer, maybe it represents a percentage and it has to be between 0 and 100. But often you don't need to know those things. So the single most important piece of information is just the type. Is it an int? Is it a float? Can it be multiple types? What multiple types can it be? most of the time you're taking in a number or returning a number. It's kind of interchangeable between int and float, but not always. Factorial has to have an integer. It wouldn't be wrong for it to return a float, but given the way it works, it wouldn't really make sense. It's always going to return a whole number, so you could write factorial that returns a float, I guess, or you could just write factorial that returns an int, and if you really wanted it to be a float, you could cast it as a float, I guess. So something like that, right? So I'm just keeping track of types. So I do this first call, and I'll write the head, and then as soon as I have a conception of what I think I need to return, I'm not really going to think too hard about what to name this. You want to give things good names in general, but the thing is, I could just call this res for now. It's a placeholder, and it gets me typing. You know, a lot of times the important thing, I can't stress the importance of just typing, you know. Just get something down. So I'll call that res for result. I was too lazy to think of a name. For I in range. I'll write my logic, n+1. And then I'm going to say res times gets I. Well, you know, I look at this and I think, well, you know, I could improve that name a little bit because I'm doing this times equals thing. Prod. Let's call that prod for product or something like that. That's just an example. So you want to every time you name a variable, like sit for a second and think, can I think of a good name for this? And if you're sitting for more than 10 or 20 seconds, just be like, this is a list. I'll call it list, LST. Or it's a number, I'll call it n or num. Or it's a character in a string, I'll call it character. Or it's a string, I'll call it text. Or this is the result of the function that I'm going to return, I'll call it res, you know. So I have those like kind of preloaded easy variable names that aren't really that descriptive, but at least they tell me something about the type. They're pretty generic. I know how I use them. It's a little trick that I have. You can do that or not, but the point here is, you know, like try to think of a good name. If one doesn't come right away, give it something generic. You can always come back and rename it later, you know. If nothing else, name it something that relays the type to you. So I'm putting a lot of emphasis on type. So anyways, so this is an example of a specific workflow that I would use. So just again, to recap that, I have a factorial function. First thing I'm going to do, call the function factorial. We'll invoke the function. Just give it a test. I know this. Take a note on something about what I expect. In this case, I just know the answer. Def factorial. Take an n. And return prod equals 1, etc. Right? And the etc. part is solving the problem, but everything up to this part is like a scaffold, right? So I know that since I have this call, if I get stuck or confused at any point in the function, if I have a typo or whatever's happening, if I have a misconception on what something is returning or anything that I'm doing in the function that isn't actually what's happening, this sometimes is called driver code, right? So it'll invoke the function that I'm defining. So I have now the option to run my code, right? So, oops, poured. So yeah. So the short story of this is that this is kind of the opposite of the. I give a pretty different example, and I apologize for that, but it's kind of the opposite of the, you know, like have a fully conceived idea, and then document that idea, and then ensure that idea really is the right idea, and then implement something. Because if you do that, especially if you don't test it while you're implementing it, then what you're end up with is probably going to be broken. But if you say, okay, I get the gist, it's time to start writing code, and you just start writing, that process will help you discover what to do and how to solve the problem. That process of just writing will like get you through the rest of it. So yeah. All right. What he's asking, can you set the parameter of the function to a specific data type? In certain languages you can. It is the one thing about, so remember we talked I think in the first class about Python being duck typed. It's a loosely typed language, or it's non-statically typed, excuse me, dynamically typed, which means that if I make a variable or anything, I don't have to declare that this has to be of a specific type. So there is a feature in Python called type hinting. I don't teach it, but I'll give an example of it. And if this is confusing to anybody, you don't need to know this, but just as an answer to the question, this is valid Python. But the problem is it doesn't do anything. So there are other languages where something like this would do something, but in Python, type hinting exists, but it's just inactive. It's an inactive feature. It's like, just doesn't do anything. It's kind of weird. So let's return in. So I said factorial takes in in, and in has to be an integer. And then I returned it, and then I'm just calling the function with a string, and nothing happens. So this isn't actually going to enforce the type that I asked it to be, but I actually really like to do this in my own code. I do a lot of type hinting just for me, just to like, so that I can look at things and say, oh, in is an integer. I find it useful for just reading the code. But yeah, if I were going to add one thing to Python, if I got to just pick one thing, it would be that. It would be enforced type hinting. Maybe even mandatory. Yeah, probably mandatory type hinting. I think I would require it. The first time I learned a statically typed language, I was like, man, this is kind of annoying. And then I got into it a little bit, and I realized I just never didn't know what my types were. I had this constant awareness of, throughout all this code that I was writing, I just knew, I had this intuitive sense of what all the types were, because, well, it's not intuitive. I mean, I literally just had to write it, and the act of having to write it made me a better programmer, and it made me better in dynamically typed languages as well. So that is, having had that experience is why I put, I give an example, and I put such a big emphasis on keeping track of your types. So anyway, okay, cool. So that's good for review. Let's get into while loops. So I gave an example of a while loop the other day. We did the, was it next prime? We did is prime and next prime. And we can kind of look at that again, because that's actually a really good example. It's a good example of, is prime is a function that can utilize a for loop and makes a lot of sense with a for loop. We could write is prime with a while loop, although there's no reason to. A for loop does just fine, and it's just so much nice. It's much nicer code. But then there's next prime, which we can't really write with a for loop, and we'll get into why that is. So you might think, well, why would I bother learning for loops if while loops can do extra things? And to be very clear about this, any problem that can be solved with a for loop can be solved with a while loop. Although problems that are suited for being solved with a for loop should be solved with a for loop, because while loops are fairly prone to infinite loops. You get good at them after a while, and you end up with pretty good confidence that your while loops aren't going to just run forever. But it is an issue when you're learning while loops. You will most certainly get your while loops into infinite loops. So make sure you know where your stop button is in Replit. If you're working in a terminal on a local environment, you're working in your terminal, Control C will stop a running process. I know that's like copy for Linux and Windows systems, but it's cancel in the terminal. At least it is on Mac and Linux. I'm not sure about Windows. I know Windows uses a different shell paradigm than Unix systems, so I really only know about Unix systems. But make sure you know how to stop your code. So let's just look at a while loop. So the example that I gave before is a while loop is a lot like an if. So let's look at the anatomy of an if and the anatomy of a while, and you'll see some similarities, and there's basically just one small but very meaningful difference. So if takes in a condition, doesn't really take it in, it's not a function, but if we give it a condition, and then if the condition is true, we execute the conclusion. So condition, conclusion. And then once we execute the code in the conclusion, if we execute the code in the conclusion, we just keep moving on, right? So if I say A is 10, and let's just do something like B is 5, we could just say if A is greater than B, we'll just do this really simple example. Come on. Oh my gosh. Oh, okay, sorry. Print A is greater than B. And then let's print the condition is finished. Or let's just say the program is finished. Okay. So no big surprises here. You probably have a sense of what's going to happen. We have a couple variables. We see if one is greater than the other, which it is in this case. And then we're going to print, just do something in here. And then once that happens, it's just going to move on, right? So a while is similar, except once it gets to the end of this, it comes back up and checks the condition again. So it checks the condition again, and if the condition is still true, then it executes the conclusion again. And then once it finishes the conclusion, it checks the condition. If it's still true, it executes the conclusion. So it's caught in this cycle of checking the condition, executing the conclusion. So basically what this means is whatever stops your while loop, some component of it has to change in the loop, right? So I could run this. This is valid code. Oops. Here, let's do this. You can see what's happening. It's just, I'm trying to select this text, but it's just, it's running forever. And I can feel my computer getting a little hot. Okay, cool. So this loop is going to run forever. So let's do something like this. So the way we usually control a while loop, like I said, is we have to have something in the condition change. So I'm going to do this. So while it's true that controller, I'm just going to call it controller, while it's true that controller is greater than 10 or less than 10, we'll just print the controller. Yep. Okay. So I run this and I get a bunch of zeros. So I need to increment the controller. Okay, so now it stops, right? So what happened here? Controller started at 0, and let's do something like, let's just do it till 4, right? So controller started at 0, our controller started at 0, and then is the controller less than 4? Yes, 0 is less than 4. Okay, so controller plus gets 1, we'll print it off, we print 1, and then is 1 less than 4? Yes, it is. So controller plus gets 1, controller's 2, print 2, 2 is less than 4, increment controller, print controller, prints 3, 3 is less than 4, increment controller, print controller, controller is 4, 4 is less than 4 is false, so the while loop stops. So that's the gist. So you always have to make sure you have something that's controlling your while loop. So in general, well, I say in general, but I actually think in every case, even if it's not something like in the yeah, one way or the other, something in the loop has to change in the conclusion of the loop, right? So something in the loop body has to change that affects the condition that breaks the loop. So let me show you an alternate way that I will sometimes write a while loop. So sometimes you'll see this, while true. So remember, like an if, right? If the condition is true, well, A greater than B, this is an expression that expresses, meaning it gives back a value, it expresses a Boolean value, right? So you might remember me saying a condition is any expression that expresses a Boolean value, any expression. Well, true is an expression. It expresses true, right? So it's what's called a literal. 0 is an expression that expresses 0. So when something is an expression that expresses the thing that you wrote or the thing that you see, it's called a literal, right? So this is an integer literal. 1 is an integer literal of 1. True is a Boolean literal of true, right? With a value of true. So it doesn't seem like an expression in the same way like 4 greater than 5, right? But it is. It's because 4 greater than 5 gives back a Boolean value. Just like true gives back a Boolean value, it just happens to give itself back, right? So while true, this is effectively saying run forever. But we can still control this loop in other ways. We can have an if. We can say if controller is greater than 4, greater than or equal to 4, break. And I'll put my control logic. So what I personally like to do, I go out of my way at least a little bit. I won't go out of my way a lot, but I will a little bit. I'll change things in order to accommodate my my desire to put my control logic as close to the top of the loop as I can, preferably wherever that change to the thing controlling the loop is happening. I like to have it, and this is just purely out of like my own preference of how I like to organize my code. It's not going to change the way it works. I could write this so that it increments kind of anywhere, but I like to have it, if I can, as the very first thing, the very first line in the loop. And the reason for that is so that I don't lose it, so that I can keep track of where everything is. And you might think, well, how would you lose it? So maybe it's not as big a deal now, but when I was first learning coding, I would like lose the places where I was altering my controller for my while loops, and it was just a nightmare. I would end up with these while loops that were like 50 or 100 or 70 lines long, these huge loops. And I was a beginner, and it was what it was. But my rule of thumb has never changed. So it can be helpful. You don't have to do things exactly like I do them, but keep track of where your alterations to your controller are. For me, that system just involves putting them in a place where I know I can find them. It may be the case that a while loop may have multiple changes to the controller. There may be cases where I would decrement the controller and then increment it again, and then or add different numbers to it. And that's kind of the power of a while loop, right? The thing controlling how many iterations this has is like the way that I want to alter this controller that's going to gate this loop. Gate meaning, to turn it on and off. Is totally in my control. It's totally up to me. Whatever logic involved in incrementing or decrementing or changing this controller is utterly in my control. So what that means is that while loops are well suited for solving problems where we can't determine how many times some process should be repeated until we just perform the process. And I'll give you an example of this by contrast with for loops. So let's look at a for loop. And we'll kind of write that is prime, next prime logic again at some point. So a for loop, if I know I want to repeat something 3 times, I can say for I in range 3. If I just want to repeat something n times, I can do for I in range n and return. No, I'm not return. Print. I don't know. Just whatever I want to repeat. Repeat. We'll say hello. Okay. Hello, hello, hello. If I want to do it 30 times, okay. So in this scenario, I know how many times I want to repeat some process, right? Let's do something a little different. So let's say I want to write a function. Let's say squared squares list is a function. Its input is a list of integers, or numbers. We'll just say numbers. Numbers is an integer or a float. And its output is a list of numbers. Calculates the square of each number in the input list and appends it to the output. Okay. So bearing in mind, let's do like a little like workshop breakout for this. So bearing in mind the bonus thing for today. Oh, where is it? What is workflow? In good workflow, if I were going to adopt a good workflow pattern for this, what's the first thing that I should do to approach solving this problem? First thing, very first thing. Go ahead and put it in Slack. Okay, we got some things. So define a test, invoke, set the test condition, invoke, yeah. So we want to invoke the function. Now, I mean, we're invoking something that doesn't exist yet. So it's kind of weird. So print squares list. And the great thing about this is it makes me think about the problem, right? It makes me think, okay, well, if I pass it a list of like 2, 3, and 4, and I'm going to just do those because those are easy numbers to square in my head. I expect a list with 4, 9, and 16. You know, and I could do others if I wanted, but you know, that's fine. Maybe I have some contingent where it's like, what happens if I get an empty list? Well, I think if I got an empty list, I probably just want an empty list. No big deal. Okay, cool. I'm not even gonna worry about that second case, but I'm just showing this to say, like, if there were edge cases or other cases that you wanted to test for, just kind of do multiple redundant cases just to be sure. I mean, I do that. Even when I'm like, I don't need 2 tests here, but I'm nervous and I would feel better if I saw 2 correct results, you know, and if for whatever reason one's correct and not the other, then there's something more that I have to understand here, right? Okay, cool. So this is going to take in a list. I'm just going to call it list. And it's going to return squares. So that was about as long from when I let that breath out that I didn't even mean to do that, but I'm like, that's always how I feel like, oh, I've got to name this variable. Oh, okay, what am I going to call this thing? That's about as long as I like to wait before I'm just like, res, you know. And then I'll come up here and I'll think, okay, that's actually going to be squares, and then I'll go, okay, I'll name it squares. But just give yourself a couple seconds. If you can't think of something, just name it something that gives you a sense of its type, right? This gives me a sense of its type as well because it's a plural, right? If I name a variable like squares, it should be a collection of squares. If I name it square, it's probably just the square of something, just one integer or one number. Okay, so let's do this. Let's say, okay, this is what I was building up to. So y'all did good. We write the test first, and then I'm kind of guiding us through the rest of this, right? So at this point, do I need to use a for loop or a while loop? Let me make a poll real quick. Let's say you can emoji react, foot, or whale. Okay. Foot for for, whale for while. Okay. For loop, eh? But what about, you know, I don't know the size of this list, right? At the time that I'm, because this list could be of any size, right? What if it was this? Does that change anything? Anybody want to change their foot to a whale? No, people are holding strong. Good, yeah, you all know this. But I wanted to point this out because this is something that I find people thinking occasionally where they're like, well, I don't know necessarily the size of the list. So does that mean I don't know, I can't determine the size of the list to tell me how many iterations I should get on a for loop? And we don't know the size of the list, but it doesn't matter because a for loop just handles that. For num in list squares dot append num squared. Right, you could use range, somebody's pointing out you could use range len. Yeah, good. So when you have a list, if you intend to iterate through it, in like I need to do some operation, in this case squaring the number and appending it to every object in this list, in this collection, that's a pretty common, there's a huge set of problems that fit that description, right? It's a pretty common thing to want to be able to do, and a for loop is just designed for that purpose. So they're nice and easy to use. They just make that nice and easy. They give us a name for each element in the list. For a number, we get to call it whatever we want. We can enumerate it and get the index also. We can change where that index starts with enumerate. We can iterate through multiple things with zip. So for loops give us this wide variety to make kind of like really common iteration tasks nice. So they're great. Let's do another for loop problem. Let's do is prime again. And this time, you saw me write it before. And I think there's some is prime problems in learn that you may have encountered at this point. So if you know how to write is prime, go ahead and get started. I'm going to write a quick spec for is prime, and I'm going to just put 5 minutes on the clock and just get in your is prime functions. If you have the code of an is prime function somewhere, don't just copy paste it. Do try to do it from memory and do it in good workflow. Call it first, write the head, write the return. You don't have to have the return fully realized. Just write in a return. It can be whatever. You can always change it. You always move it around. Okay, so is prime. Inputs. Um, we'll just say n. You can call it whatever you want, but I'm going to call it n, which is an int. So it's just input. Return bool. Cool. If you want a spec for your is prime function, here's a quick one. Now this is a for loop function. I'm going to give you all a bit of extra time here. I want to see a few answers for this. I want to make sure we get in a few answers for this, give people an opportunity. Okay, cool. Another few seconds on this. Okay, cool. I'll take a shake at this. So is prime. So first thing is I got to write some tests. So I'm going to think, what is, oops, let me get a little bit more light in here. It's a little better. So what is this function supposed to do? What kind of testing would give me a positive signal about whether this function is working or not? So it's supposed to return true when I give it numbers that are prime. Okay, so let's try something like that. So print is prime with a prime number, and false with numbers that are not prime. So it occurs to me, I could actually just throw this in a for loop and test it in a for loop. I could say for I in range, and then just pick a range. I'm going to pick 20 because that's what I like to do. Just a nice, it's a few numbers, it's big enough so that I can see 20 different results, but it's not huge so that I don't need to see 200 numbers and know whether they're prime or not right now. So we'll just do that, and then I'll feed it I, and then in terms of what I expect this to give me, I could go through here and say 0 is not prime, and 1 is also not prime, and 2 is prime, right? I could do this, but I like to I like to save time, so I'm not gonna like necessarily go through and determine every output at this stage, right? So this is, and I bring this up because this is a good part of testing, is right to choose, if you don't want to go through and like map out a whole big thing for an expectation on the output, choose a set of inputs that you can understand intuitively. So I can look at a number under 20, and if I don't know right off the top of my head, I can think about it for a second and think, is that really a prime number? Is that meant to be a prime number? So I can just kind of recognize the prime numbers under 20. It's not that hard, right? So let's do def is prime. We'll take in n, and we want to return. I know we want to return a Boolean And I actually know which one to return, but often when I'm setting a Boolean in a return or in a value or whatever, I just guess. I just pick one. I'm not going to try to think through all the logic of the problem to figure out where it should start or stop. I'm just going to remember that there was a place where I guessed. If it helps, you just leave a comment at the end with nothing on it, and that'll kind of stick out to me, and I'll be like, oh yeah, I made that guess there. I'm not totally confident on that, so maybe I'll come back and check that. Okay. We have got an edge case here. If a number is less than or equal to 1, we're just going to say it's not prime. Not a prime number. And of course I want to return it. For all other numbers, we can check for I in range. And we can start at 2. We don't want to start at 0. Because we're going to be checking every number in this range if n over that number, I, has a remainder, so that's modulo, of 0, then I know I is a factor of n, therefore n is not prime, so I can return false. And if I start I at 0, then I'm going to be doing n over 0. Modulo gives you the remainder, but it is a division operator, so this will still give you a 0 division error, so we don't want to start at 0, right? Okay, so maybe we want to start at 1. Well, that's another problem, a totally different problem, but also a problem. Everything's divisible by 1. So in this case, in the remainder of n over 1 is 0, because literally every whole number is divisible by 1. So this is going to tell me that every number is not a prime number. And I know that some numbers are prime numbers, so we don't want to do that. So we want to start at 2, and we want to go up to, there's a few places we could go up to. I'm going to do the square root of n. So I'm going to do n to the power of 1 over 2, which is the square root of n. And I'm going to cast that as an int. I'll just show you what happens if I don't cast that as an int. It says float object cannot be interpreted as an integer, and it points at that line with the range, and I just happen to know that the range function can't take floats as its arguments, right? It's very particular, it needs integers. So we're going to do that, and I actually, since the square root of a number is a valid number to check, a number may be divisible by nothing other than its square, so we want to include it. Excuse me, its square root, not its square. So we'll include that square by adding 1 to it. So n to the power of 1/2 is the square root. I just want to make that an integer, and I want to include that square root. So I add 1 to it. That's what all that is. Okay, cool. So we got a nice, decently optimized is prime function. There are other optimizations that we can do to is prime to make it even hairier and scarier. Except I forgot to come back to my guess, didn't I? Because look at my test. So I got to this point, I ran my code, make sure it's right. And this should give you a sense of how important it is to run your code, right? I'm teaching the class, and in teaching the class, you know, I know what I'm doing. I'm a good programmer, and I got this far, and I forgot I made this guess here. Now I do know that this needs to be a true here, but I was, I'm pretending. Okay, well maybe I'll just make a guess. I could just guess and come back to it, but I'm not worried about, did I guess everything correctly? the way I solve problems is I run my code. Did it do what I wanted to? No, it gave me all falses. It says none of these numbers are prime numbers, and I know some of them are. So I'm like, okay, right, yeah. So if I make it through this whole for loop here, sorry, I'm just cleaning up these conditions. If I make it through this whole for loop without returning false, the return stops the function and therefore stops the loop midway through its tracks. So if I make it through without stopping the function for returning this false, then I know it's a prime number, so I actually want to return true. Great. So this says 0 and 1 are false, 2 and 3 are true, 5, 7, 11, 13, 15 is false, good, 17, 19, okay. So you can see, I like to give, I at this stage in my development, my professional development, I'm pretty confident that I can write a function like this the first time, but I've gotten it wrong so many times that I never believe it until I see it. You know what I mean? So I do really want to say that, like, it's okay to need to run your code to know that it works correctly. I don't parse this by eye and be like, yeah, that's right, it's fine. I'll get it to a certain point and I'll run it, and then a lot of times it's wrong, and I'm like, oh, it's not there yet, and then I need to go adjust something, and then I go adjust it, and that's just a normal development workflow. So what I'm trying to say, the takeaway from that is run your code a lot. It's good. Um, if you've ever heard anybody like talk about like getting the language to program itself, getting the language to do the work, that's where it happens. You run your code a lot and you'll kind of get the feel for it. Okay, so now let's write a function that requires a while loop. So I'm going to go quicker through this one. This is going to be the next prime. Why am I doing this here? I should do this here so I can utilize my isPrime function. Next prime is going to take an in, and it's going to return the next prime number. Okay, so, well, I said I would do this one, but it's while loops. So we have to write a while loop. And I know you've seen me write this function before, but you can search your memory, try to think your way through this one. Next prime takes in a number and gives me the next prime number after n. So let me write a spec for it. Go ahead and start writing it. I'll put 5 minutes on the clock after I get in the doc string for this. Next prime takes in n as an input, returns, actually also returns an int. Locates the next prime number after n. And returns that number. So let's say n equals, so if n equals 12, we expect 13. If n equals 13, we expect 17. If n equals 14, we expect 17. Super secret hint, these 3 lines give you all the information that you need to know to write a test. They are essentially tests because I'm making an assertion that this function with this this input gives me this output. So you could write 3 tests for that. You could write more tests. You could do the for loop style tests that I did for the is prime. That's usually what I do for next prime as well. So again, start with your tests, follow good workflow. This problem will require a while loop. You have seen me do it before, I think just last class. So good luck. Somebody's asking, shouldn't the last test be n equals 17 should return 19? The last test that I have written says if n equals 14, it should return 17. So 14, 15 should return 17, 16 should return 17, 17 should return 19. You are correct, though, that 17 should return 19. So the question has changed. For code efficiency, shouldn't the last test be n equals 17? So n equals 17 should give back 19. Well, like I said before, I would say that writing tests is not a place to worry about efficiency. Writing tests is, if anything, like the opposite. Like if I can solve a problem with 3 tests, but I feel better using 18 tests, I'm going to use 18 tests. You know, so in terms of like in terms of this, this is actually a unique situation from these other two, right? Where 12 returns 13, which is just the next number. 13 returns 17, which is not the next number, but 13 is a prime number, and 17 is the next prime number. 14 is a similar test to 13, except it's starting with a non-prime. So to me, this actually covers a unique case. It's still a unique case. So I want to make sure if the input is prime, I get the next prime, and if the input is not prime, I also get the next prime. So it's a good, yeah, it's a good question. I'm glad you're asking this stuff. You're welcome. Good. Okay, that's time. Maybe we need a little more time though. We've got only a couple answers. Yeah, I want to give you all a little more time with this. Oops. Do another minute. Make sure everybody, I'm going to give this a good honest shake. I want everybody to give this an attempt. Even if you don't get an answer in, I want you to give it an attempt. I expect that all of you are in your REPLs trying this. You know, unless you're, I know other people, you know, it's late, you know, you might be having dinner or, you know, kind of listening passively, and that's okay too. But if you have the bandwidth to be typing in REPL, then definitely do so. Do make sure you run your submissions in REPL. Or in any environment. Oh, you got some tests in there. We're starting to get some more submissions here. I'll give you all a little more time. See if we get any more. Got 1 more minute on the clock. Okay. All right. Cool. Got a lot of good answers. Okay. I'm going to show a solution for this. Print. We'll do next prime. And I'll follow suit with what I had before, 12, 13, 14. Now I could do more. You could definitely do more. This will do fine for now though. And this will be 17 and 13. And then we'll define our next prime. So we want to return, and I have this already in my head where I know I'm going to increment n. So I'm going to return some value of n. I'm going to call it n. So for this, we'll say while not is prime, and I'm using my prior is prime function. While not is prime n plus 1, because I want to check the next number, then I say n plus gets 1. And I saw somebody, so here I've got 12, 16, and 16. It's because I forgot to adjust my return. No big deal. Just go back in and adjust it, right? Okay, so I saw somebody do a variation of this, which is where they did that, and then they're checking n. And this is totally acceptable too. If that, I saw that and I thought, oh yeah, you know, that kind of, maybe that makes it make a little more sense. Like just increment n out of the gate, so whatever it is, just add 1 to it, check if that number is prime, and then, you know, if it's not, then move it up and keep doing that until it is, and then return it. So, you know, it's just a variation on it. Saw some good solutions in there. Now, with something like this, I am tempted to start playing around with it and say for I in range 2000, print I and we're just going to do if I, if is prime I. So if I is prime, then we're going to print the next prime. So you're going to see these pairs of prime numbers, right? And now I could start doing interesting things. You know, if I want to see the distance between these prime numbers, oops. If I want to see the distance between these prime numbers, I could do it this way. Right? This is going to give me what's called prime windows. Maybe I do a prime windows list. So list, and why don't I just append these instead? It's a long name. Prime windows dot append. Let's append those. And then I could, why don't I take this and print the sum of it over the len of it. Oops. And that'll give me the average distance between prime numbers between 0 and 2000, which happens to be like 6.6. Just as a side note, you know, like you can start, that's the cool thing, like you have a test and sometimes you can start playing around with it and doing interesting stuff, you know? Did you know that the average distance between prime numbers between 0 and 1000 is 6.6? I did know that actually because I've done this a lot of times before, but I still find it interesting. So, because I would have thought it would have been way bigger than that. Anyway. So that's kind of, I mean, another, it's definitely a side note, right? This is starting to turn into like my test has turned into something kind of cool, and I should probably turn it into a function. Probably turn it into like a prime Windows list function of some kind, so we could do something like that. Cool. Let's move on with while loops. Cool, so let's do this breakout. This is going to have you write a function. Write a function that computes and returns a list of all divisors of some positive number. And it wants you to use a while loop to do this. And you could use a for loop. So I would try the while loop way first. Usually I tell you try the easy way first, but I want you to just try the hard way first, just so you know when you try the easy way, you can be like, oh, that way sure was harder. So go ahead and try the while loop way, and if you get finished and you still have time, try doing it with a for loop as well. We got 5 minutes on the clock. I'm extending the time a little bit for this one and give you plenty of time. I want to give folks a chance to get in on answers for this. Okay. So we're a little shy on time. Hopefully you got a good burn out of that one because it's a little hard to solve this problem with a while loop. It's a little challenging. It's a bit easier with a for loop. And if you look at this for loop logic, you're actually going to find a lot of similarity to the is prime function. Actually, you will in both of these, but you'll have a little bit more similarity in the for loop solution, obviously, because I wrote it with a for loop. So this is kind of the same or similar thing, right? We're starting the range at 1 and going up to and including the number. In this case, there are different like divisor sets, some that include 1 and some that don't, and some that include the number and some that don't. So, but this one includes both. And then same sort of deal here, you know, if num mod divisor equals 0, then instead of returning, we just append it and go on and check the next one. And then once we're done doing that, we've got divisors. So interestingly, you could use this, either one of these, as the basis for an is prime function, because if you have a list of divisors that's only 2 long, well, every number is divisible by 1 and itself. So if it's only 2 long, it's a prime number in this case. So yeah. We're going to pick back up with while loops next time. We're about a minute and 30 seconds before our official stopping time, so I think this is a good place to wrap up so we don't end up like covering something too quickly or not having it be meaningful. So I'll wrap up the recordings here and we'll open up for questions in just a second.